Well, hello, everybody. I hope you all had a wonderful and safe weekend. Here is your assignment for today, writing an equation from a table algebraically. And in your Canvas post, there are some slides. Now, you're not required to turn in these slides today with answers and graphs because you're going to be solving these algebraically today. So you'll need to upload a copy of your work so I can see that you're following the proper steps to solve these tables algebraically. Okay, so what we're looking at today is writing an equation from a table as we're learning about functions, about modeling and predicting change. So let's go ahead and begin with what we already know from last week. We know that when we're talking about the y-intercept and reading the y-intercept from a graph, that it's the point where the graph crosses your y-axis. So if you look at this picture here, and you can see that my line crosses the y-axis at 0, 3, and so that's going to be my y-intercept, okay? Then we also learned how to read a y-intercept from a table. So we look for where the x value is 0, and of course in this particular table, we see the x value is at 0 and the y value is 4. So that's where I have 0, 4 graphed right here on my graph. And that is my y-intercept there. And then we also learned how we can find the slope and then take the slope plus the y-intercept and write a linear function or a linear equation to describe this line. Okay, and you'll hear me using the term equation and function interchangeably as I go through this presentation today. You also learned how to find the equation of a line using Desmos. And this is probably by far the easiest way, I think, where we just enter the values in the table into Desmos, and then we type in the formula. Y1 is approximately mx1 plus b, and that at the bottom gives you the parameters, which is your slope value or rate of change of 2, and your y-intercept or your starting point, initial value of 6. Okay, so those are the things that we already know how to do. Now, how can I write a linear function algebraically? Okay, and the reason we're learning this today is because by far I think writing a linear function using Desmos is the easiest way to do it. But there's other methods, and as you progress in your math career, you are going to have to know how to use the y equals mx plus b linear model to write equations from points. So that's what this is really designed to teach you today, as to how to use this linear model y equals mx plus b to write equations just having points and slope of a line. All right, so let's look here at our first example, which says, given the following table of values, write a linear function. All right, so if you look at your table of values, we do not have the y-intercept clearly identified because it doesn't give us an x value of 0 that we can pair a y value with. So if you look here, and if you want to pause the video and write these 4 steps down, you can. The first thing we're going to do is find the slope. The second thing we're going to do is select an ordered pair. The third thing we're going to do is substitute slope and the ordered pair into the linear model, y equals mx plus b, and then solve for b and write a function, okay? So if you need to pause and write those down, you can. And as you do that, I'm going to flip to my Canvas board and we'll start showing you the math of how you can do this. All right, so here's the table of values for our first problem, and we are trying to write a linear function simply by using what's here in the graph, and we're looking to do this algebraically. So my first step is to find the slope. So we know that the slope or the rate of change is going to be the change in y over change in x. So if I look here at my pattern, I have 7, 10, 13, and 16. So this entire change in y is increasing by 3. Then if I look at my x values, 1, 2, 3, 4, well, that's pretty easy to see. That's increasing by 1. So in this particular table, my rate of change or my slope is going to be 3. So that is my first step, is to find the slope. The second step is to select an ordered pair. So you can pick any ordered pair you want. I'm going to pick the easy numbers to use, which are 1 and 7. So I have a slope of 3, and I have my ordered pair of 1, 7. And I'm going to label my x and my y. So now my third step is basically to substitute the slope and the ordered pair into the linear model y equals mx plus b. So I have here the linear model y equals mx plus b. So let's start substituting. So from my ordered pair, my y value is 7. So I'm going to substitute 7 for y. My m value, or my slope, is 3. My x value for my ordered pair is 1. And all of that's being added to b. So the fourth step is to solve for b and write a function. So 3 times 1 is 3. So 3 plus b equals 7. Subtract 3 from both sides. b equals 4. So therefore, my linear function for this is going to be y equals 3x plus 4. And again, you don't have to complete these slides. I'm just doing it for the sake of illustration. All right, so let's go on to the next one. Okay, so here's our next example. Given the following table of values, write a linear function. So again, we're going to do the same things. We're going to find the slope, select an ordered pair, substitute the slope and ordered pair into the linear model, y equals mx plus b, solve for b, and write a function. All right, so here's our table. So we'll just follow the steps again. Slope is the change in y over change in x. So if I look here at my y values, I have -4, 2, 8, 14. So my pattern on this side is +6 because I am increasing by 6 between each of my numbers. If I look at my x values, I have -1, 1, 3, 5. So over here, my pattern is +2, or they're all increasing by 2. So here my slope is 6 over 2. So 6 divided by 2 equals 3, because I use my normal rules of fractions, and if I can simplify, I want to simplify. So that was my first step, is to find the slope. Now we say select an ordered pair. Again, you can pick any ordered pair you want. This time I'm going to pick the 1 and the 2 because they are positive numbers, and I would rather work with positive numbers than having to worry about negative numbers. So I have here 1 and 2. And again, that's x and that's y, and m equals 3. So then the third step is to substitute the ordered pair and slope into the linear model. Y equals mx plus b, solve for b, and write a function. So again, y is 2, that's taken from the ordered pair. My slope is 3, my x value is 1, and I add all of that to b. So 3 times 1 is 3. Subtract 3 from both sides, and I have b equals a -1. So here, my linear function is y equals 3x minus 1. So that means where my x value is 0, my y value is going to be a -1. All right, and let's look at our last example. So we had our know, we had our wonder. Now we'll see everything that we have learned today. So again, given the following tables of values, write a linear function. So we're going to find the slope, select the ordered pair, substitute, and then solve for b. All right, so here's my table of values again. So again, I'm going to look at my change in y over change in x to solve for the rate of change or the slope. So my change in y is 4, 6, 8, 10. So that is increasing by 2. So that's plus 2. Then I have negative 3, 3, 9, 15. So all of these are increasing by 6. So my change in y is 2. My change in x is 6. All right. So I then have m equals 2/6, which will reduce to 1/3. So in this particular problem, again, my slope is going to be 1/3. Then we select an ordered pair. So again, I'm going to pick numbers that are easy to use. So I'm going to avoid the negative. And this time I'm going to again pick 3 and 6. And like I said, you can pick any ordered pair you would like, because since we have constant rate of change, it's going to work for any ordered pair that you use. All right, so there's my slope and my rate of change. So now, my slope and my ordered pair. So again, I substitute this into the linear model. So my y is 6. My m is 1/3. My x is 3 plus b. So 3 times 1/3 is 1. So my y-intercept, or my b value here, is going to be 5. So then, there's my function. Okay, so hopefully you see that this is a very useful method when your y-intercept is not obvious. For example, in here, this example, it's obvious your y-intercept is going to be 6 because you have 0 for your x value here. But in the case we just did here, as well as here, it's not that obvious, and the countback method may not work the way it works in other problems. So that's why we have the algebraic method to use to solve this one. Okay, so for the rest of your assignment today, you can do the rest of the slides 10 through 16. Okay, make sure you show me all of these steps that I just showed you. Upload a copy to Canvas, and then tomorrow there will be an assignment on comparing functions. That's Tuesday. Wednesday we will have a progress check on linear functions. Have a great day, everybody. Have a great day. And come and see me on Google Meet if you have any questions or if you just need to chat.